Hi, I'm Marti McCurdy with Spirit Electronics, here again with Ben from Raycon, and we'll ignore the peanut gallery behind our camera because they're having too much fun without us back there today. So anyway, thanks for all the education you're giving us, and this last tech talk we'd like to talk about is testing technique, which kind of hits home for me because that's really my background in semiconductors is bringing test and qualification to devices. So this is kind of near and dear to my heart, and I know this is like your sweet spot also. So when we have customers that are dealing with embedding these oscillators from Raycon into their applications, sometimes there's issues that come up with noise and environmental environments that they're in that, you know, sometimes they're funny, sometimes they're not, but basically meeting the customer's needs specific to the data sheet is the key piece, right? People are ordering these parts so that the data sheet specifications are what they want to design in. And let's talk a little bit about the support Raycon offers when the customer's application isn't seeing that the data sheet's being met. Basically, that's what happens.
Sure. For me, that's the fun part. I love getting out into labs, meeting with customers directly, working out the various issues. And there are a lot of issues. When customers are trying to verify performance or trying to repeat the performance that we get in our labs, especially for some of these higher performing devices. We have some very high performance OCXOs, the RK410 for example for space applications, and the HSO14 for ground applications. These are devices that are doing Allen deviation down at 1 part in 10 to the 13 at 10 seconds or better. Pretty much top of the line in the industry. Or phase noise that's down at -120, -125, -130 at 1 hertz. These types of measurements are very finicky. There's a lot of things that can go wrong in the lab to make it difficult to repeat that sort of performance. So yeah, I love getting out in the lab and helping out with various things. Sometimes it's environmental factors, sometimes it's airflow, or it's temperature instability that's going on.
Or we're in the Bay Area, maybe there's an earthquake.
Right, vibration can be a factor. You can have people, long-term measurements that people are trying to do, and somebody comes by with a cleaning cart and bumps into the table. And for those of us that have been dealing with oscillators like this for so long, we can see those sorts of things pretty clearly with 1 or 2 looks at a frequency plot or a phase noise plot, where we can say, hey, that kind of looks like you've got some sort of noise coming in from the outside world, whether it's a power supply or a fan, for example. I've seen that. So all these things that over the years of dealing with oscillators, we've seen pretty much everything.
Yeah, I guess that's a testament to the sensitivity of it, right? It's actually picking up everything that's out there. One thing that I'm not sure I remember exactly the parameter it is, but you talk about accuracy and meeting the data sheet. When I first was looking at the Raycon parts, when we all joined up as partners, I thought it was ppm, but it's really ppb. You're at like per billion.
Parts per billion, in some cases parts per trillion.
Yeah, that's amazing.
Parts in 10 to 12, parts in 10 to 13. And as I was mentioning, that HSO14 ultra stable OCXO is 8 parts in 10 to the 14 Allen deviation at 10 seconds.
Wow.
The only way you can measure a device like that is with another one of those devices. There really aren't other things on the market that are at that level. So the reference, for example, that's another thing that's often a critical factor that people overlook, is as these devices are getting higher performance, you need a better device as your reference. Otherwise, all you're doing is measuring the noise of your reference, or the noise of your measurement system.
Amazing. Well, I know that Raycon has one other one, is the LNO1000. Could you touch on that one?
Sure, that's a ultra low phase noise ovenized SAW oscillator. That's a surface acoustic wave oscillator. So these are devices that run from about 250 megahertz up to about 5 gigahertz and provide best-in-class phase noise. Phase noise floors down to -180 or so, even at a gigahertz output.
Wow.
The huge advantage in comparison to starting with, say, a 10 or 100 megahertz device and having to multiply up and having that phase noise floor lift as you multiply up. When you can start at a gigahertz with a 180 minus 180 DVC floor, it's a big advantage for applications where that phase noise is critical.
Yeah, that's amazing. It's good info. Well, I really appreciate that you're here to support Spirit as well as the FAE for Raycon, and so if anybody needs support on any kind of embedded designs that they're working on, that they can give you a call.
Absolutely.
And we appreciate your time, Ben. Thanks so much. It's been great having you on Spirit Tech Talk.